Today we are going to start working with logs. So important to know with logs here is we have something in exponential form or log form, and we're going to be converting back and forth between the two of them. So first of all, you can see right here in exponential form, we have y equal to a base b raised to the x. Okay, so why do we need a log? When we don't know that exponent, we can guess until we get it, or you can take the log of it. So once it's in log form, we have log with a little base b of y equals x. So you see on the log form, the x is alone, so you're solving for it. In exponential form, your y is alone. So we're going to practice going back and forth and writing in log form and exponential form. So here, write the exponential equation in log form. So we can see 25 is equal to 5 squared. So let's identify what y, b, and x are. So 25 we can see here is our y value. Our base is 5. And what's happening to 5? It's being squared. So we know 5 squared is 25, but let's write it in log form. So in log form, we do log of our base b, so our base of 5, of 25 is equal to 2. So 5 raised to what power is 25? Your answer is 2. So log base 5 of 25 equals 2. So for example 2 here, we have 3 raised to the negative second equals 1/9. Okay, so let's identify our y, our b, and our x. So for this problem, our y, or the one that's alone, is over here on the right. So our 1/9 is our y value. Our base is 3, and it's being raised to the negative 2. So we know 3 squared is 9. The negative makes it flip over, so it becomes the 1/9. So log base b. So log base 3 of 1/9 equals negative 2. So people come up with lots of different ways to remember how to do this. You always know your base is going to be the small little number at the bottom. And lots of times people just know that the x and the y's switch sides. So like on number 2 here, 3 to the negative 2. So the 3 and negative 2 are on the same side when it's in exponential form. And when it's in log form, the 3 and the negative 2 are on opposite sides of the equal sign. For our third example here, we have a base of 9 being raised to the 0 is equal to 1. Okay, so our base is 9, so log base 9 of our y value. Our y value here is our 1. So 9 raised to what power gives you 1? That would be the 0 power. Okay, now we're going to practice writing it from log form to exponential form. So sometimes people do something called the log roll. So let me just show you what the log roll is. The log roll is we start here with our base, raised to this power, equals the 216. Okay, so again, what is our base? Our base is 6. So we take 6 and we raise it to the third. And 6 cubed is 216. So just take a look at that for a moment and make sure you see how everything moved around. So 6 cubed equals 216. Our next problem here, we have a base of 4. So 4 raised to the negative 1 is equal to 0.25. So 4 raised to the first would just be 4, but if we flip it over with that negative sign, it's 1/4, which is the same as 0.25. And here, log base 12 of 12 equals 1. So our base is 12. So 12 raised to the first is equal to, well, itself, 12. Okay. So what does taking the log of something really mean? Sorry. Log base b of y equals x. So b raised to what power of x will give you y? So again, we're finding that exponent. So these next ones we're going to evaluate without a calculator. I'll show you later on how to do it on a calculator. So log base 4 of 64. So what does that mean? It means 4 raised to what power is going to give us 64. So if we take our 4 and we do 4 times 4, we know we have 16. 16 times 4 gives us 64. So how many times did I have to multiply 4 by itself to get 64? 1, 2, 3. So log base 4 of 64 is simply 3. For example 8, we have log base 10 of 10,000. So two things here important. First of all, this base of 10 usually is not written. So I'll show you another one where it's not written. If nothing is written, you know it's a 10. So 10 raised to what power will give us 10,000? Log base 10 of 10,000. Okay, so let's go through. If we did 10 times 10, we have 100. Times 10 more gives me 1,000. Times 10 more gives me 10,000. How many times did I multiply 10 by itself? 1, 2, 3, 4. So log base 10 of 10,000 is 4. For number 9, we have log base 5. So 5 raised to what power gives us 1? Okay, so the only way we can get 1 if we're starting with something larger than 1 is we must raise it to the 0. Anything raised to the 0 is 1. So log base 5 of 1, or log base 12 of 1, or log base 100 of 1 has to equal 0. Now we've got log base 2 of 2. So what are we asking here? We have a base of 2. So it's 2 raised to what will give us 2. So 2 raised to just 1 gives us 2, right? So our answer is 1. If it was log base 3 of 3, log base 10 of 10, log base 5 of 5, etc., it would be 1 for your answer. Now we have log base 3 of 1 over 27. Okay, so let's first look at that 3 and that 27. So again, our base of 3 raised to what gives me 1 over 27. So again, if we just look at our 3 first, if we did 3 times 3, we get 9, and 9 times 3 gives me my 27 that I want. Since it's not just log base 3 of 27, it's log base 3 of 1 over 27, we know we have to have a negative exponent in order to make that fraction flip. So instead of positive 3, our answer is negative 3. And for our last problem here, 12, again, our base is missing. So if the base is missing, we know that base here is 10. So this is saying 10 raised to what power gives us 100. So log of 100. 10 raised to what power is 100? So all we need to do here is 10 times 10 is 100. How many times did we multiply 10 by itself? 2. And that is all for your notes for today.